Okay, so my name's Howard Greenberg. We'll be talking about XPages performance. I'm from Florida, and we have a lot of slow drivers in the left lane. And hopefully your XPages are not like that, but at the end of the session, you at least know if they are running slow and where the bottlenecks are and how you might be able to improve those. Okay, let's see. Change the slide. Okay, a little bit about me. I've been around forever. Been a certified ellipse instructor since the R3 days. I co-founded TLCC with my partner Paul. Some of you know him. Some of you have taken our courses. Back in 1987, long time. And I've been an IBM champion for the last couple of years. Before that, in a previous life, I worked for IBM in the personal computer group. I actually started the day they started shipping the first PC up a hard drive called the XP, long time ago. And prior to that life, I was a CPA for a couple of years. And actually, this is recent. I just passed the Certified Information Systems Auditor exam. Don't ask me why. But wanted to kind of tackle a different thing. It actually was interesting because they did stuff, IT stuff that I had never done. And actually, a lot of the concepts in terms of the auditing, similar to accounting, what you do for financial audits. Kind of a different, something different I wanted to try. And I'm also a flight instructor. And for those of you who know Carl Tyler, follow his Facebook pages. I was not his instructor, so don't blame me. Carl's a good guy and he's very safe. So a little bit about TLCC. A lot of you have taken courses. Our courses are self-paced distance learning courses that you take using your Notes client, Domino Designer. We also, Paul and I, do application development for a number of our customers. We can also come on site and do project classes, and we also have helped many of our customers with their specific development needs or questions and work with them. Typically, you just use GoToMeeting or something. So if you ever need some extra help, give us a call. What we're going to talk about today, let me take a quick poll. Back in October 2013, I did a webinar with George Krauser on XPages performance. Did anyone take that? Got a handful. Okay. So I'm going to repeat some of that information, but I have a lot more information. But I have to repeat it because you have to understand the architecture and the basics of what's really going on under the covers to understand XPages performance. So I'll try to go through that part quick. At the end of the webinar, I'll have a link to where you can watch that. At the end of the session, I'll have a link to the webinar. So you can watch that session we did in 2013, and it goes into a little more detail. And I want to spend some time on some tools that you can use to analyze performance and spend a lot of time going through one case study of an XPages that a typical beginner developer might create, lots of @db lookups and db columns, and take that through about 7 different iterations and show the performance changes as we improve on that. And then I have a shorter case study that we'll get to if we have time, or I'll go through real quick, we'll see. And hopefully I have time for questions. And I'm between you guys and getting drinks, so I have a feeling, you want to be out of here in 55 minutes. So what affects XPages performance? If you look at this chart, basically we can sum it up as everything. If we look on the client side, you got the browser, type of browser, the operating system, the usual, how fast is your client, how much memory, hard drive, all that good stuff. Then you got to send a request out over the network. So you got your network performance. And then finally it gets to the server, and you got a whole bunch of variables that happen on the server. So let's talk about what happens on the server. First of all, the operating system and the hardware on the server are going to have to get that networking request, pass it on to the Domino. Domino has its own networking TCP/IP protocols and software stack. Then it says, oh, this is an HTTP request. Let's pass it on to the HTTP task in Domino. The HTTP task says, oh, this is XPages. Let's pass it to the XPages runtime engine. And on the XPages runtime engine, it says, okay, this user wants this particular X page. I got to bring it into memory. Or the user might have been working with that X page, so I got to restore it from disk sometimes. And then the Java code that makes up your X pages is going to run and generate the HTML and everything else that has to send back to the browser. In the course of doing that, it's going to go through what's called the JSF lifecycle. JSF is Java Server Faces, and that's what Domino XPages are. They're built on Java Server Faces. Also, this is Domino, and you're typically going to want to serve up Domino data. So your XPages engine is going to have to access your Domino data, right? So all that has to happen before it can send the request, or the response, I should say, back to the client through the, going back through the same process via the network to the client. A couple variables on server performance you might want to be aware of and work with your admins to fine-tune. First of all, on the server side, clearly, hardware is important. How fast is your CPU? How fast is your network? How much memory do you have? How fast is your hard drive or hard drives? Because typically in Domino on a server, we want to have multiple hard drives with, one for the operating system, maybe one for Domino, one for, the admins know all this stuff. Paul's an admin, so Paul can tell us about all that stuff. The best way to configure your Domino server. So I'm not going to get into that. I'm a little rusty at admin. On the XPages side, there is a setting that controls how much memory that the Java virtual machine that the HTTP task uses. And the default is 256 megabyte. You can change that and make that bigger. A lot of people do make that bigger. And I'll show you the XPages toolbox, and there's a way to see how much memory your Java virtual machine is using and let you decide if you need to increase this variable. But if you have a lot of memory on your server, you might want to increase it from the default. Again, that's 256 megabytes for a Domino 9 server. 8.5 might be different, depending on what version you have.
What's the advantage of increasing it?
You don't want your Java virtual machine running out of memory. Okay, otherwise it could, it's going to start paging the disk, or it's just going to crash. Okay, so you want to keep monitoring that to make sure that you're not approaching anywhere near the limit.
Do the agents use the same one, Java agents?
I don't think they use the same virtual machine. I think it's a different virtual machine.
It's a different VM, I think.
Yeah, I think it's a different one. That's why they don't talk to each other. If you do change it, you need to set a second notes_any variable. That's the one down here, because otherwise, when you install a fix pack, it'll revert back to the default. So if you're going to make a custom change, you need to use that second notes_any too. One thing I didn't mention is anyone here run a 32-bit operating system for their server? Probably not. I mean, now we're talking, but that has a limit in terms of how much memory the HTTP task can use. I think it's 2 gigabytes. Probably not affecting anyone except for maybe your old test servers that are sitting in your closet. The number of HTTP threads is also important. That's it. I think it's in the server document somewhere. I don't remember. I think the default's 40. But don't go increasing this number without reading this article that I have here, because if it's too many threads, that's not good too. Okay, so it's not like you can just add a bunch of threads and your server's going to perform better. Okay, it could actually run slower. And that article explains it. If you're using HTTPS, encrypting all your web pages, that's going to be slower too. But obviously, you may not have a choice in that. Another setting controls, this is XPages related, and you see it in the XSP properties file. Everyone's seen this before, wondered what it does? Okay, so the default from IBM is what's highlighted. And so let me explain what this does. So when the user first loads up an XPage and they're starting to work with it, it's brought into memory. So what this setting does is say what happens once it's brought into memory and we serve up a response to the client, what happens to that XPage in memory? Are we going to keep it in memory, or are we going to put it, cache it out to disk. So if we keep it in memory, obviously that's going to be quicker. And we can set, if we choose that option, it's a setting, it's probably hidden, but there's a setting, a number of, right there, it's grayed out. How many pages do you want to keep in memory? And that could cause the memory issues and cause your JVM to run out of memory. It'll crash. So you got to be careful with this one. Basically, you kind of have like a memory leak going on all the time. It's always using more and more memory. The other option is keep it on disk, but then whenever the user interacts with that XPage, it has to bring it from disk again. It has to restore the view, is what it's called. So IBM suggests the highlighted setting, which if you look in the XSP properties file, that's called
Howard,
yeah.
The audio's coming really bad. The last speaker we had some trouble with, if it might have been his phone.
Move your phone
Take
away
your phone,
from.
just take your phone
Sit
away.
it
up.
Try that.
Okay.
It really sounds bad. But
All right, is that better?
I don't know.
I can move this up a little too. Maybe that helps.
It could be a battery on the phone. I don't know. We
Okay.
can hear you in the front, but
You guys hear me okay?
Are you guys in the back?
Okay, I'll try to speak louder. So the default, IBM suggests keeping the default. So that's going to keep only the current page the user is working with in memory. And when they go to another X page, it'll take it out of memory. And that tends to be a good compromise. Okay, this other setting here, what it does when we turn this setting on, and again, you probably might have seen this in the XSP properties file. When we turn this setting on, the XPages engine will try to group as many of the JavaScript files and CSS files together. So then it will only send, theoretically, one big file down to the client. It doesn't quite happen that way, but it does substantially reduce. And actually, let's go look at this to see what it does. Okay, so let's see. Let's look at our XSP properties file, and on the persistence tab, here's that setting, and I'm going to turn it off, and then I'll go to an X page. Let's look at, how about this one? And let's load that up in the browser. Okay, and then I'm going to turn on Firebug. Okay, so I'm sure most of you use Firebug or have some other browser debugger. I'll hit Control F5 to make sure everything gets loaded fresh and not from cache. And notice here's all these files that it loaded. Okay, 40 requests. So we have the actual X page itself. Then everything else is JavaScript or CSS files. So you see it has all the timing. So some of these files are pretty small and loaded quickly, but nothing can happen until they're all loaded. So let's go back to Designer and go back to that setting and turn it on. And do another Control F5. Now we went down to 14 requests. So pretty significant savings. Why you might want to turn this setting off is that when you're developing, it's sometimes very helpful to see what files are getting loaded and where they came from. So if you're looking at a particular piece of CSS, you want to see is this the CSS file I created and what's the name? You don't want it aggregated with a bunch of other CSS files, because then you can't really trace it back to the origin. So once you go into production, you definitely want to use this setting. Let's see. Okay, so we talked about the XPages lifecycle. And, what is this? So before we get into too many details, let's have a little test here, or a little survey, if you want to call it that. Okay, so I have a very simple X page here. Okay, so let's look at the source so you don't think I'm doing anything funny. And we have one input text control. And it has, in that input text control, we have a rendered property. And that rendered property has a formula. It's going to write out to the debug toolbar. and it returns true. So in other words, we always want to show this input control. And then we have a button, and the button is just going to do a, kind of hard to see, it's just going to do a, can't get over there. Yeah, probably don't need that. Let's drag that over some more. A nice, oh, this probably doesn't need to be so big. Okay, there we go. Okay, so you see it enough that it's just doing a full update. Okay, so when I first load this in my browser, we can go into our debug toolbar, and that rendered property ran once. Okay, so let me hide that. Okay, so I'm going to put some values in here and post it back. So how many times do we think that rendered property will run? How many people think it'll run at least once? Everyone raise their hands. It's got to run at least once. Okay, so everyone raise your hands. Okay, so how many think it'll run twice? Okay, a couple of hands. 3 or more. Think it's going to run that many? 3 or more times? That's a lot. Come on, 3 or more times? 4 or more. Got some people hanging in there. 4 or more. 5 or more. But you don't count. 6. 6 times. 6 more times. 6 or more. You keeping your hand up to 8? Okay. 7 or more. 7 or more. You got a couple. Okay, who says 7 or more? 1, 2, 3. Okay. Let's go see who was right. All right, so we go into our debug toolbar. I'll refresh it so you don't think anything funny's going on. And we count them at this time 7 times. Okay? So what does that say? It says if we had something that took a long time in that rendered property, and we had 20 input controls or edit boxes that were all doing complicated stuff, this is really going to slow down our XPage performance, right?
Why does it do that?
Good question.
The plan.
Because of the XPages lifecycle. Okay, so why does it do it? Because it's going to go through this entire process whenever we do a post. Okay, so when I first loaded that XPage, it's a GET request. You see that it only happened once. Well, that makes sense, you know, that's to figure out what's going on. But now we're posting back to the server. Now this JSF lifecycle comes in. Again, this isn't something IBM necessarily invented. This is part of the JSF architecture. And we have all these different phases. So the first phase is it's going to restore the view. So like I said before, when you first load up an XPage, if it's something you are already interacting with, it has to pull it in from disk or memory. Memory, depending on your setting of what we showed you before. Okay, the next thing that has to happen, and by the way, let me point out that if you ever seen that after restore view event on the XPage, that's when this is going to run at this point, at the end of this phase. The next thing that happens is phase 2, apply request values, that's what it's called. And so we have all these editable type controls on the XPage. The user typed in information in those controls. And now we have, in memory, we have all our controls, or called components, a component tree. And we need to take that data that was sent up from the browser and attach them to all these controls. Okay? So that's what happens in phase 2. Okay? Next thing we have to do is we have to take that data and we have to validate it. Say, those are all your validations. Everything that's server-side validations happens now. Now, some of your controls might be number-type data, right? So we got to convert the data. Everything in the browser is a string. You got to convert the data to a number, or whatever it has to be converted to. So those are the converters. And at this point, if we fail validation or conversion, it goes to the render response phase. But assuming we didn't fail validation, then we go to the update model values. That's all that is taking the data that's bound to the controls and applying it to your back-end data sources, your domino document, your fields on the domino document. Okay, so that's what happens there. The next thing we do is, here's now your code that you put in buttons and all the different events. that's when your code's going to run in the invoke application. So all the on XXX type events on click, the code is going to run in the phase 5. Finally, we get to the last phase. The last phase is called the render response, and that kind of does just what it says. It's going to figure out what do we need to send back to the browser, what HTML and everything. Okay, so let's look at a little X page I created. And let's see, we don't need this one anymore. This. Let me try to keep these closed as best as I can. Actually did this one. Okay, so I have an X page here. Pretty simple. I have two controls. So one, let's look at this one control here. We're computing the label. Okay, and when we compute, do any sort of computation on these various controls on this X page, I'm going to print out to the debug toolbar. And I'll print out some identifying information, basically print out the ID of that control. So that's the label property. We also have a rendered property. So all these controls have a rendered property. So that's the label. Here we have an edit box, and we have a validation. And a default value property is what I'm highlighting here. Again, we output to the debug toolbar. We got a validator. So this one control has a validation. And what else do we got? We got a rendered property as well. Here's another label, has a rendered property. Here's a combo box, and the combo box has a rendered property. And it also has a computed values, so we're computing what values the user should see. Okay, again, putting a message in the debug toolbar. What else were we doing? We have computed fields. The computed fields have a rendered property, and these two computed fields have the same formula. It just puts, outputs out the current time, so you can see what time it got executed. Okay, so let's run this and put some information in, change the values, and I'll submit it. And actually, I didn't want to do that just yet. Let me first, in the debug toolbar, and if you ever see Mark Lusink, he's the one who created the debug toolbar, make sure you give him a big thanks and buy him a drink, because this is a fantastic tool. And in the latest version, you can enable the lifecycle debugging. Let me clear the messages here and try this again. What's this? Because you'll see exactly what is going on. So by turning on that feature, it actually outputs what phase it's at when the processing happens. And so you see that we did the restore view, then we did the request values, and in the request values, it did all the rendered properties. And again, I don't really know why it thinks it has to do with them. I'm sure there's a good reason that you ever see Phil Rion, you can ask him. Then in the process validations, well, of course it's doing the, I don't know if I can see it very well, but it's going to do the validations, right? So there's one line there for that one control we're validating. It does all the renders again. Some of the renders happen twice, like on the combo box. And it does the values for the combo box. In other words, figuring out what list of choices we should show the user. Then in the next phase, phase 4, does all the renders again, some of them twice for good measure. And then we get to the 5th phase. Here's where our code in the button was executed. And finally, we get to the render response phase, where it did everything again to figure out what HTML to send back to the browser.
So how did you do 7 previously?
If you count, they're twice. If you go, you'll see it in the slide I have next. Okay, this is what happened when we did the initial page load. It just does, when you first load up an XPage, it's just going to do the render response phase. So we only had 12 server-side JavaScript calls. So to answer your question, this is what happened. This is basically just summarizing up what happened, what I was showing you in the debug toolbar. But some of these happen, for the labels, happen twice. So where is it? Wednesday. Somewhere in here you'll see the label got done twice. So, oh, not the labels. It was the input text got done twice. So, yeah, some of them. It's actually, oops. Okay. So there's a lot of computations going on. 39 server-side JavaScript calls here. Quite a lot. So what can we do about that? Well, probably the easiest thing to do whenever you're writing code and working with the script editor, when we first start doing XPages, this is the default, compute dynamically. Why change it? It's the default. But why change it is what I just showed you, right? Think for a second, is this value really going to change when the user is working with the XPage? So as they're interacting with the XPage at that moment, until it actually gets completely loaded again, is the value going to change? If it's not going to change, then always choose compute on page load. So it's only going to execute when the page is first loaded. Okay? But then, if it is going to change, it's going to execute every time the page is rendered, and not just once, because I just proved to you, it's going to be, depending on what it is, it might even be 7 times. So, to show you just this, how many people have used this option before? Compute? Okay, a couple of you. So, just for those of you who have not, let me just show you real quick where it is. And here, so if you go into the editor, compute on page load, that's where you'll set it. And what it does, if we look at the source pane, it puts a $ in front of the code. Okay? So that's saying compute on page load only. If it puts a $, that means it's compute dynamically. So what does that buy us? So if I take that same XPage and I take all the renders and make them compute on page load, and also the combo box, if I take the values property that's computing the list of choices for the user, we're only going to do 6 server-side JavaScript calls. I saved 33 computations. Okay? Pretty significant savings.
Does that translate to significant savings in time?
Yes. Yes, it does. And again, it depends on what you're doing in the render. If you're doing it, what you're doing in the rendered is just reading like a scope variable out of memory, it's going to happen lightning fast, so it's not going to really matter. But if you're doing @db lookup, then you're going to be slow. And we'll see that in the case study I'm going to do. Okay, so if you need dynamic rendering, that was an excellent question, because what do? You use scope variables. Scope variables are always in memory. Okay, remember we got request scope, view scope, session scope, application scope, which have different lives, and can be application scope can be shared by all the users. How many people have used data context? Okay, we got a couple. Okay, what a data context is that you can compute a value and kind of bind it to the XPage level, panel level, or a custom control. And then you can refer to that value later on in your XPage with just the expression language. So if you called your data context, gave it a name of my data context, you can just in the expression language say my data context, and it's going to be a lot quicker. But if you are using data context, for those of you who are doing data context, did you set it to be compute dynamically? You remember? A couple of you? That is like the worst possible case, because that's worse than the renders. It runs like a couple extra times. So you try never to set the data context dynamically. If you always set it on page load, and then Mr. Withers has an excellent blog entry. He'll tell you how to set the data context via code. So if you do need to change the value in your data context, and typically we do, that's the whole reason we're using them, you can then just set it via code and not have it actually compute in the data context.
To bind to page beam, is it just as quick?
It'll be quick, yes. I mean, it's still going to happen multiple times. I think I've seen the chart 6 times. I think it's actually more like 7 or 8. I could, I don't want to, I can show you later. So I kind of took out a couple slides here that I kind of illustrated this because I wanted to kind of spend some time on the case study that I have. Partial refresh, partial execution, how many people use that? Probably almost everyone, right? You know, these are great. Partial refresh is not only a performance thing, which is why it's in my slide deck, but it's also, from a user interface point of view, you know, you don't want to refresh the entire X page if you're only changing one part of it. You just want that one part to change. So that's what partial refresh does. Partial refresh, however, will compute the entire X page, right? The only difference is that it figures out, oh, you only want to partially refresh this little area, so I'm only going to, in the render response phase, do what's in that one area you specified and send that back to the browser. So clearly there's some benefits there. Partial execution, on the other hand, will only execute what's in that one area you specify, but it'll send back to the browser the entire X page. And if it's going to send it back to the browser, that means the whole render response happens for the entire X page.
So I'm a little confused on that. If I'm just doing something here,
Uh-huh.
I probably want to use partial execution because I don't care about anything else. I'm just not taking something. ID is that
Let me show you. We'll see what the difference is. Okay, so if we look at just partial refresh. Okay, so I have the same X page as we had before. This time I said for computed field 2, let's just partial refresh that. So in the button here, I said in my events, partially update panel 1. Panel 1 is what's in yellow. Okay? And I run this, and it's going to do what we think. Put in some values here. You notice the time only changes for what's in the yellow. Okay? So that's, what we think is going to happen, and kind of what you said. But if I look at what's happening under the covers, all those renders still ran in all the phases for the entire X page, except the render response. We only did what was in the yellow area. So we saved 9 server-side JavaScript calls, okay, which is good. We also only sent back to the browser what was in the yellow area. That's good too. And the user didn't see the whole X page flicker and change or whatever. They just saw that one little area in the yellow change, which should be hopefully, pretty seamless for them. Some of the cons is that you can only refresh one area. So ideally, typically you put what you want to refresh in a panel, but sometimes you have panels that may be not contiguous. So there's a workaround from Tim Coney, who's still contributing, even though he's not with us anymore, greatly to our work. And he has an entry, it's actually on the XPages wiki, is the best place to see that. So his workaround lets you chain some partial refreshes. Okay, didn't want to go there. Kind of showing what happened. Okay, so now let's look at just partial execution by itself. Okay, so I have the same yellow area. I had to move the button into the partial execution area because in the button I'm saying now I'm going to do a full update, but I'm going to say set partial execution mode and only select what's in the yellow. So if I want the code in my button to run, it has to be in the partial execution area. Kind of makes sense, right? Okay, so let me run this, because there are some side effects to this. Okay, note the times, right? 6:20, 32. Okay, look what happened. What happened to the user data that was entered? It got lost, right? And notice the times for both changed, but I said only partially execute that one area. Well, what happened is kind of easily explained or seen when we look at the chart and look at our print statements or debug toolbar statements. We only partially executed what was in the yellow. That's our computed field 2. And we did the on-click event for the button. But in the render response, we did everything. So our default value got computed again, overwrote what the user entered. We did the combo box. Everything got computed again. And also, in the apply request values, we didn't do those controls where the user entered the data. So whatever the user entered was lost, right? It never got bound to our controls, so then it never got sent back to the browser. So if we look at some of the pros, clearly we had less processing, but the cons, you got to make sure that whatever control is kicking off the event is inside your executable area. Any editable areas outside of the executed area don't get submitted or updated. So you don't want to go back to the office and turn this on for all your XPages. That's not going to be good. Is everyone on AD108, by the way, previous servers? Production? Anyone on APOD? Couple? Okay. Hopefully you're not on APOD 1 because there is no setting in Designer. But even is anyone using Designer APOD? Not just your server? A couple of you? Okay, so you won't see the area to select the area to partially execute. That won't be in the user interface on Designer APOD. But you can go in the source pane, and I think it's called exec ID equals, and you can put that in your event and get around that. Or just upgrade it down to 9 and compile everything for A5, and if you have to use an A5 server. An unenviable position. Okay, again, went too far. You can go through this stuff, as much as you can, and you still forget. Okay, I gotta stop at this slide and go to Designer. Okay, so let's say we use them together. Okay, so in our button, I'm going to say partially update and partially execute the same area. So now, when we run this, put in some data, click on the button, it works the way we wanted it to. Our user entered data is still there, and the time change in the yellow area. And even better, let me go to that slide here. Look at how much we saved. We only did 6 server-side JavaScript calls compared to doing the whole page where we did 39. So
That almost doesn't make sense. So if you do the partial refresh, you do so many calls, but if you add another refresh once you execute, you do less calls?
no, we're not doing 2 parts. We're doing one's refresh, one's execution.
Oh,
So it's
use a
2
full
different.
refresh?
Yeah, no, we're doing, in this case, we're doing the, let me go back to Designer again. In this case, we're doing both the partial refresh, partial executions here, and partial refresh here. The same panel, what's in the yellow, panel 1.
Yeah.
So we're doing them together. So working together, we get the most performance benefits. So wherever you can, try to, combine those. Which should be most of the time when you think about it. Okay, so has anyone ever wondered what the loaded property is? The loaded property is like a permanent rendered, okay? So if you say loaded is equal to true, it's going to be, available to use. If loaded is equal to false, this happens when the XPage is loaded and the component tree is built. So you can't go back and then say, no, I want to compute this later on. You can't change it at that point. So once something is not loaded, it can't be rendered later on. So clearly that's a performance benefit too. Okay, so what do we want? What do we learn from this? First of all, it's not all doom and gloom. I was talking about the rendered property. Not all the properties are like that. So if we were computing the CSS style property, oh yeah, I want this control to be red sometimes and green other times. That only happens in the render response phase, no matter what. But what you do have to watch out for are the rendered properties. And if you need a rendered property to be dynamic, then you want to think of how can I speed up what's happening in that rendered property. The other thing is when you just need to update part of the XPage, use partial refresh and partial execution whenever you can. Okay? Okay, so let's kind of switch gears for a second and let's see how can we debug performance issues. Well, one is print statements. Print statements print out to your log file. They print out to the server console. So you can put in some print statements. Hey, what's going on? How many times is it getting run? And put those in different events maybe. You can even set up a little timer if you want. The debug toolbar, you can do the same thing. The debug toolbar is cool that you can also, let me see if I have a page up. In the debug toolbar, let's see if one of these pages had a debug toolbar. Okay, here's the debug toolbar. I can actually go in and enable show milliseconds. So it'll actually go in and you can kind of really get to the millisecond level what's going on. So the debug toolbar is very helpful actually for developers where you might not have easy access to the server console. The debug toolbar is going to be right in the browser. Highly suggested. The newest version runs as a plugin, OSGI plugin, so it's you don't have to add it all the XPages to your application like you did before and copy over the Java code and all that stuff. It's just there. You drag it over. Okay, so on the server side, you have tools. Windows Server has the tool to look at your CPU, your networking, your memory usage, all that good stuff. I showed you before how to use the browser debug tools. If you're using the Notes client, there's a Firebug Lite that you can drag over to your XPage. That is basically the Firebug debugger for the most part. And then we got the JavaScript debugger you can use to trace through and see what's going on. The best tool for performance measurements is probably going to be the XPages toolbox. How many people have used this before? Okay, a fair amount of you. The XPages toolbox is it's a Domino database. You're going to put it on your Domino server or your Notes client. Then you're going to copy over a jar file to your server or your Notes client. Then you got to modify the Java security policy file. And by the way, you never put this on a production server. And not only your admins not let you do all this stuff, but it's just not secure. You always want to put this on your test server. And you got to modify the Notes ini file. All these steps here are in the README file, but there's some excellent explanations in the XPages book, Mastering XPages, in the second edition. I don't know if it's in the first edition, but it's in chapter 20. So if you have that book, you can go back and look at chapter 20. The XPages toolbox, I'll explain what it does in a second. Here's the link, and it's on OpenNTF, where just about all the good stuff is. So what we can do with this is we can go to the XPages toolbox, and we can turn on a profiler. And we can profile either CPU time or what's called wall time, which would be the total time. CPU time would just be the time the CPU is doing something. So we're going to turn on this profiler. We're going to go to our XPages and we're going to do something or some things. Then we're going to come back to the XPages toolbox and turn it off. And it's going to then put a detailed listing of all the stuff that happened when that XPage was executing. Okay, and it'll show you the total time for that task or tasks, and then it'll break it down, and you can even see where the bottlenecks are. That's one function of it. Another function is we can profile what's going on with the Domino objects. So we can look at the Domino objects, the calls to the Domino objects, and say how many calls were made to get entry by key. How long did that take? And we can kind of get an idea of the interaction with the Domino data. You can do memory monitoring, see how much memory is free. You can do session dumps, and I haven't quite figured out how to use those. I don't know if anyone's worked with session dumps. It's all in XML format. I don't know if I'm missing something, but I've figured out how exactly to use those. You can do heap dumps of the Java virtual machine. So that's going to take everything that was in memory at the time you did the dump. The only way to really see that is then install the Eclipse Memory Analyzer tool. And if you do that, you also have to install the IBM dump tool, is what they call it. And that's going to just tell the Eclipse Memory Analyzer how to read these IBM formatted files. So I get the links to both of those up there if you want to try it. And also this will, the XPages toolbox will do thread monitoring. So these are all helpful. The first two bullets we'll look at, and those are definitely the most helpful. Here's a picture of the CPU profiler. We'll go through an example of this live. But you see that it has our XPage that we were running. First of all, it starts off, it's all categorized. So this is when we did this profile here. And then it has the XPage name and breaks it down, goes by categories through the different phases. It even tells you some of the phases, the phase it was at. So that's pretty useful for kind of zooming in on where your XPage might be slow. The back-end profiler, again, you use these buttons to start and stop the profiler. When you click stop, it puts a document in this little embedded view. And then you click on whatever one you want to look at. And at the bottom, it shows a table. These are probably familiar. You got all your classes and methods you called, how many times it happened, and how long it took. Okay, so very useful. A little bit about @DB lookup. So, of course, when we first started out, hey, we're a nodes programmer. @DB lookup, this is cool. I recognize this. Nice and easy to do our lookups. Well, I did a little experiment. This DB lookup went to customers by name view to a certain name to get the phone number. Here we use this server-side JavaScript, nothing fancy. I'm doing in 2 lines what we did in 1 line, getting the phone. Did it 500 times, and you see a pretty significant performance decrease or improvement. So stop using @DB lookup. Okay, it's not going to take you that much longer. So at least write the server-side JavaScript code. I'm not, and by the way, when I do this in Java and call it to Java, where it's actually doing the lookup, not trying to cache anything from memory, it was basically the same speed. So arrows coming in. Paul? Sorry, Doug? No, actually, Paul's pretty good, but there's some folks who say do everything in Java, which is great. I mean, when if you get there, you get there. But it's clearly a learning curve. Okay, so let's get to our case study. I want to spend some time on this. So let me show you this application, because if you don't know what I'm doing, you're not going to really understand the changes that I make. So let's look at this application. And actually, let's first run it, just so you get a good idea of what it is. Okay, so basically, the user can select a username, and it shows you a repeat over all my customers. I don't have a lot of customers. There's only 42, and that's it. When I don't, depending on the user selected, for the regular user, we don't want them to see the sales. Okay, so I actually had a little rendered property on there. That's the only place we used the rendered, was in the sales column. So let's look at the application. Let's make this a little bigger. Okay, so I have 3 databases in my application. First of all, in our customers database, this is just storing data in the views. We have a view. This is the view I'm going to be repeating over. All my customers, and we got columns for the city and the name. And then in the same database, I have another view, a different set of documents, where I show for each customer is in a certain region. And so being a good programmer, we don't want to hard code in the name of the representative too, because they come and go. So we have this little view to let us look up the name of the sales rep for a certain region. And then we also had, close this here. And also had a view, not that one, this one. Okay, a view had all our users and what role they play in the database. They're either a manager role, sales role, or user role. So that's my customers database. Then I have a sales database somewhere. And these are all our sales orders. Okay, so in this case, they're categorized by the customer name. And if you remember from what I just showed you, the goal was to get the total sales for each customer. So we got to do a lookup, or maybe not a lookup, at least get some code that's going to go through these customer orders and add up all the orders for the customers. Okay, and then finally, in terms of the background, being a good programmer, I don't want to hard code in the path and the file name of my databases where the data is. So I have a little configuration view that we can do a lookup to get the location of all my configuration values. Okay, so pulling this all together on my X page, we have to select the user. We have code that does a lookup, in that case at DB column, to that view I just showed you that has all our users. We also did a lookup to our configuration view to get the configuration, so we can display that. When they click update, it's all that does is a full update here. I'm getting a scroll bar, but you can see the full update there. Okay, then I have my repeat, and the repeat is just repeating over that view that you saw. View 1's that customers by name view. And then in each of these fields in my repeat, I display the customer name, so that's pretty straightforward. For the address, I didn't have that in my view, so I had to actually go to the backend document and get item value string, get the address. The city was in our view, so we just kind of bound to that with the expression language. The state, I had to do the same thing with the get item value string. And the region was also, I had to open up the document to get that. Okay, so to get to the sales rep, that was in a different view. So first I have to get the location of the customer database. And then I got to get the region field for that customer, the region value. And then I got to do a lookup to the sales rep view to get the region. Then for the sales, so remember this one has the rendered property. And so we got to do a lookup to the user info view to get the name of the user to see what role they're in. And finally, for the sales value itself, I had to go to the sales database, find the loop through all the customer orders, and sum up the total of their orders. So a lot of stuff going on in the repeat. Okay, so our users, let me see. Avoid me getting confused, let me close what we don't need. Okay, so here's our application on the server. I'll load into memory. And hopefully I still get a network connection. If not, I can do it locally. Okay, I'll load that into memory. I'm not going to use the debug toolbar. I'll just get that out of the way. Keep that out. Okay, let's look at the, this is, we're a new XPages programmer. This is our first application. And now the users are saying, hey, it's kind of running a little slow. So we go to the XPages toolbox. Someone told us about that at an MWA conference. and we go to the CPU profiler and say, what are they talking about? It's still loading. Let's go profile this and see, what kind of times are we getting? What's going on with this application? Maybe thinking about it. Oh, it was just working. I have the backup. I can do it locally if you need to.
Okay, everybody turn their cell phones off.
Okay. I always have fun when you're demoing. We'll just load it locally. But to do that, I need to load the XPage locally too, because this is only going to profile on the same machine. You can't.
Same idea.
Okay. So yeah, so the times might be a little different than what I'm going to show you, but you'll get the idea. Okay. So I go over to the CPU profiler, and you see some previous profilings that I've done. I'm going to reset the profile, and let's look at the wall time. So I'll start the wall time profiler, go to my XPage, and that's all I'm going to do is choose one of these users that are going to show the sales column here. And it's done, so I'll come back, I'll stop my profiler. So now let me show 100 entries here. And if you choose this hierarchy of dominators on the left side, it'll show you, kind of hide everything at 0. So you see that we start off, we did the request, the restore view phase, nothing really happened there, that took a lot of time. Update model values. So you can kind of look to see what times and what happened. You see that in my, oh, that's an older one. In my render response, it took 249 milliseconds. But then if I drill down into it, you see that this JavaScript expression here happened 42 times and took 59 seconds. So you can kind of get a rough idea of what's going on. So it looks like a lot of the time is being eaten up by DB lookups and calls to the back end, domino objects. So let's go over to the back end profiler tab, and let's start the profiler and go back to our XPage and do the similar action. Update it. And if we look at the back end profiler, okay, so oh, we're going to stop it. Thank you. Yeah. So if I stop it, there's my session that I just profiled. I click on that, and at the bottom, it tells me how much time it spent doing domino backend calls. And here's all the things that happened. So it spent a lot of time on evaluate. And evaluate is what happens when you have @db, at any kind of functions. So we spent a lot of time on that. So clearly we might want to improve upon that. So what's the first thing I could do? So I'm going to kind of take this step by step, and I probably will go a little over. I don't think they start till 7, so if you guys hang in there. First thing I did was in the, if you remember, we were getting configuration values out of the configuration view. So what I did was in the before page load event, we're going to check to see, we're going to create an application scope variable called config map. So if this value is not initialized, in other words, if it's null, so it's not initialized, we're going to go to the config view and get loop through all the entries in that configuration view. And what we're going to do is put in, I don't know if this is easier to see in Designer or not for you folks in the back. Okay, so in my before page load event, we're going to create a variable that's a Java hash map. Has anyone ever heard of that before or worked with that? So this is a way to have a variable that we can give it a key and a value. And then we can use a get call to pass it the key name that will return the value. So I'm going to set this up in the before page load event. And I'm going to use the put method to put in my, again, pass the two parameters, the key and the value. When I'm all done doing that, I'll take that config map variable, store it in my application scope. So then when I want to use that, let's see, we used it here in the sales rep. So then when I want to use that, I will just say application scope.configmap.get and pass it. In this case, I want to get the location of the customer database file. Okay, so if we look at the savings here, just by doing that one little change, I saved 1,000 backend. So the first column is our number of backend domino calls that I got from the XPages backend profiler. The second column is the time it spent on the backend domino objects. The third column is the amount of CPU time for the total XPage, just to refresh, the username. So you see that we had a pretty significant improvement by making that one little change, because we did have that in the repeat. We were using that at DB lookup to get these configuration values multiple times. Okay, so that worked pretty good. So let me try following up on that and doing the same thing with the user info view. So I'm going to load into memory all the usernames and their roles. And I'm going to make this application scope again. Application scope is shared by all our users, and it lives for the amount of time that's specified in the XSP properties file. So there's a setting. You can set how long the application scope variables live for. And the default's 30 minutes, by the way. You want to bump that up to a couple hours. It depends on your app and your apps. And you can set it at the server level or the application level. But typically you want these to be kind of long-lived. So you might want to bump up the default. Okay, so that was used in a couple places in our app. I'm not going to show you in Designer because we're try to save some time. So again, I saved almost 500 back-end calls, and these are cumulative. Okay, so I took what I did before and added to it, and we saved a fairly a lot of time in the back-end. So the time was actually not in proportion to the amount of calls. So obviously these calls were kind of time-consuming, and our CPU time went down too quite a bit. So just making those two little changes, caching things in application scope, had a pretty big change to our app. The next change was, remember in the repeat, I didn't have everything in the view, so I had to actually open up the notes document. So I just created a new view that had all the values I need, except for the last two fields in the repeat. Because one of them I got to go to a different view, the sales rep view. The other one I had to go to the different database to get all the sales orders. So this would take care of my first four columns, pull everything in with the expression language. So this had a little bit of savings. Not a big difference. Not sure, because maybe I only had 42 things in my view. It might not have mattered, but a little bit of savings there. Okay, so now we're going to get into Java and some beans. So what we're going to do is remember the salesperson's name. We were getting that out of the salesperson view based on the region. So again, that's not going to change that much. So we're going to cache that in application scope, and we're going to have a bean that gets that information when you first open up that XPage, and then keeps it in memory. So let's first look at whenever you do something with beans, memory database, we have in the basis config file. So that bean I'm calling cache bean, and it uses the cache bean Java class in its application scope. So my cache bean is going to, I have some other things in here, but initially I'm only initializing the region. So I'm going to that sales rep view. Again, I'm using a hash map to put in the information, but then I'm storing that in the bean. So we have the region hash map, And then I have a get salesperson call. That's just going to return the value, the salesperson's name. So that's the code there. And then I had, in my XPage, we were using that here in this field. Instead of doing any sort of DB lookups or whatever, I'm just going to call the get salesperson method in my cache bean. So, what did that save us? So that had a little bit of savings, especially in the time. Okay. So our back-end time changed, our CPU time went down. So a little bit of an improvement there. The next thing we want to do is getting that, obviously that going to the sales order database and getting all the sales, that obviously sounds like that's going to be kind of time consuming. So here, obviously then, we might have orders coming in all the time. So we probably don't want to set this to application scope. But it depends on your data. In this case, I chose view scope because view lasts for as long as the user is working at that XPage. Now, that's a little different than request scope, by the way. Request scope is every time you access that bean, it's going to recompute everything. Okay, but view scope will access it when we first access it, that XPage, and then until the user moves away from that XPage, then that view scope bean gets lost. So what I'm going to do is go to, bless you, I have a sales lookup, okay, and I set this up as a view scope bean. And so this is going to, when it initializes, go to our sales database, go to the sales orders by customer, and it's going to loop through getting the totals. So I actually did this a little differently too, not really any fancy Java stuff, but Domino stuff. I used the view navigator, and I'm going from category to category because I had my customer name was categorized, but I also had a total for that category. So I just said get next category, just go category to category instead of open up each document. So that was probably a little quicker too. So by doing it that way, a pretty significant savings here. Okay, because we had that one repeat we're doing 42 times. And what I was doing before was an @db lookup. And no, actually I wasn't. I was getting server-side JavaScript and getting all the entries for that customer, all the orders, and looping through and adding them up. So that was a pretty significant savings there. Okay, last but not least, we're going to do everything in Java. There'll be no basically no server-side JavaScript except when we're calling our bean in some cases. So we're actually going to have two beans. So we're going to expand upon that cache bean to go beyond just the user, the region information that I showed you. We're going to add the user profiling and the configuration stuff. And we'll make this application scope because it's something that's shared by all the users. It can last for a while. This information is not going to change. But then in my repeat, instead of binding it to a view, I want to bind it to my customer bean. And my customer bean is going to return everything we need for the customer row. Let me show you that here with this chart. So we're going to have in our customer bean, we're going to have a class I created called the cust entry class that will have our customer address, city, state, region, sales rep, sales total. Okay, and then each of those has a getter and it has a setter too, which we're not actually using on the XPage. Then when in our repeat, we're just going to say, call the customer table. That's going to return a, let's see, close that too. Okay, so let's look at that code real quick in our customer. And this is it here. Okay, so when I initialize my database, I'm going to go to the customers by name view. And I'm going to get all the information. In some cases, I got to compute the sales rep, which is, in this case, I go to my cache bean to do that. And the sales total, I got a method to figure out the sales for the customer. And then we take and create a new cust entry for every customer. And we store that in a collection. So this isn't a hash map this time. This is a Java collection. and I'm going to have a method to get customer table that's just going to return that collection. And then I have the cache bean. I won't show you that. It's basically kind of what we did before. It just expanded to do everything. And then in my XPage, the XPage got very simple, right? We just have the UI here, and wherever we need to get to data, like to get all the users, I just called my cache bean, and I had a method to get all my users that was in memory, right? In my rendered for my sales, I just have cache bean is manager, pass it the username, or is sales to tell me if it's a manager or sales person to display that column. For the values for all these are all going to be expression language bound to my repeat. The row data is my variable in my repeat. And then in my repeat, I don't bind to a view anymore. I bind to my customer bean. Okay? So what does that do? Well, I did it two different ways. The first way is request scope. So it's going to always calculate if you want fresh data all the time. Request scope. It still had a pretty good savings, right? But then when we have, once we initially loaded this, everything's now in our view scope variable for the customer bean. We basically made no back-end domino calls because it's just pulling everything out of memory. Everything's already been loaded up. And so our time went down to 100 milliseconds. So look where we started. Here's the nice graphical picture. So we had a pretty significant savings.
Can you show that in the UI to see how it looks better?
Yeah, does it look better? It happens quicker.
That's how you can look at it. I mean, it's faster.
Yeah. Yeah. Yeah, so before, so pretty much loads almost immediately, whereas before, this is our starting one, and so it took a little bit of time. Where these times are, we look at what I profiled.
You're also running local.
I'm running locally. The times I was showing were on my server, which is actually, a kind of an pretty old Dell machine that's running a 32-bit OS that, pretty slow. So, yeah, so that's a pretty significant savings doing that. Okay, so the next thing we want to look at, the next case, I'll just kind of show you the scenario and show you the times, was with the partial refresh. So our intrepid XPages programmer had their application, the same application, everyone loved it. They said, hey, I want to see the total for the region. Can you stick that over in the top right? So we just added in control here, shows all the regions, and then computes the sales. And then what we did was in the on-change event for that combo box, where is it? On-change, there we go. You see that we were doing a full update, okay? So what does that mean? That means that when we change this here, the whole XPage is getting recomputed, right? So we know how slow that is. This is based on my starting point, not the Java, the last iteration, but the starting one. So suppose we change that and make this partial update, or suppose we change it and make it partial execution, or suppose we do both, okay? So rather than walk through all those, I'll just kind of show them all. So when we just did the partial refresh, we actually had a pretty significant savings, but it still did 516 calls, okay? When I did the exec by itself, we didn't really save too much. We saved a little bit, time-wise we saved a lot. But when I did them both and just refreshed and just executed that one little area that we had to, because the rest of it didn't change, then we only had 12 calls to our back-end domino objects. And by the way, this is still using that DB lookup. I didn't try to do anything fancy here. and my time went down significantly. So just kind of, again, keep that in mind. Okay, so to wrap up, because it's string time. So think of what we talked about, the JSF lifecycle. And when you design your applications, keep that in mind, okay? Remember, rendered is bad. I mean, we need to use it, but if you're going to render, do render, try to cache whenever you can. Cache as much as you can. And do that with scope variables. That you do that with server-side JavaScript if you don't know Java. If you're starting to get into Java, then do it with beans. The nice thing about beans is you can kind of put everything together. All the logic of your application you can start to put into the beans. And then also measure performance. Get familiar with the XPages toolbox, measure everything. And so the demo databases, well, first of all, here's your homework. Ulrich and I did a session in October 2013. It's not I didn't repeat a lot of stuff. The only thing I repeated today was stuff on the JSF lifecycle. Ulrich presented some great information about working with Java and strings and a bunch of other stuff. And I think I touched more on data context and some of the other pieces there. Paul Withers has written a couple articles on the JSF lifecycle, 3 different parts. If you got a couple hours to spend, I forget how long they are, on OpenNTF, this is kind of old, but Tony McGuckin was on the IBM XPages team. He did a video, it's called XPages Masterclass, but it really relates all about this stuff we talked about. And if you want to learn more about Java server faces, if you really want help going to bed, article. This actually has nothing to do with XPages other than XPages uses Java server faces. But if you really want to understand the nuts and bolts and why, you can dig into that. The link to download everything is tlcc.com/mwlug. I noticed a mistake in my slides. I probably won't update that until Monday, if I remember. But it wasn't a big deal. But all the demo databases are up there, at least the application I showed you, the case study of it. And also we got a deal if you guys are interested in a TLCC course, 20% off any courses. There's a code that explains it all on that webpage. All right, so thanks. Any questions? Well,